Okay, we started out with a quiz and people did pretty well. Haven't looked at the details, so I can't say how well. But I think pretty well. Everything looked good when I looked at it. And we're given 2 points and trying to find the equation of a straight line. Okay. Now, first thing I'm going to do is I'm going to start with the graph, because if you start with formulas, you get the right answer, but you know what they mean. Okay. Now, OpenMath started with the formulas, and that's fine, but we want to make sense of the formulas. So I'm not even going to mention the formulas, at least not just yet. So we've got the points 2, 6, and 9, -4. And we want to find the equation of the straight line. I think you learned a lot by starting with the graph. So let's say here's 2, 6. So here's where x equals 2 and where y equals 6. And then x equals 9 maybe out here. And y equals -4. So you have a point here and a point here. Then you draw a straight line through these points. Incidentally, when you're drawing a straight line, the easiest way to get the line pretty straight is to figure out where you're going to start and then look at the point that you're aiming at. Okay? If you're focused on that point, your hand will go toward that point. Because people are pretty good at aiming. Okay? Well, there we have it. Here's the line. Now, this line has equation. Y equals mx plus b. This is at least the slope-intercept form, which in many ways is the simplest form for the equation of a straight line. So I would urge you, if you start with 2 points and want to find the equation of the line, you start with a sketch. Now, let me do this. If I move from this point, actually I'm going to do it like this. Okay. Here's my line where y equals 6. Here's my line where x equals 9. Here's my line where x equals 2. And here's my line where y equals -4. So I would sketch those lines and label them. It reinforces a lot of things about the graph and gives you a better understanding of what it is you're doing. Now, this course, I certainly don't require it. If you learn how to use the formulas, that's okay. Depending on whose course you're in, you might get more emphasis on the graph. And in my course, you get a whole lot of emphasis on the graph. Okay. Now, I can move horizontally and vertically to get from this point to this point. How far would I have to move over? And how far would I have to move up or down to get from here to here? Can you sketch that picture and kind of give me those 2 numbers? Okay. So we drew these. Now, let me emphasize, if you want to understand the picture, it's really helpful to draw the horizontal and vertical line through each of the 2 points. Okay? And label them, just to reinforce for yourself. Now, as you get better and better, at doing this, which you will after doing several problems, it becomes less necessary. Okay. Now, my question was, how far over do you have to go? If I start here and move to here, you see that I have to move over this far. And I have to move down this far. Okay. So the number you would put here is 9 minus 2, which is 7. Okay. The number I would put here, well, what number do you think I'd want to put here? Okay, now it's 10 units from here to here, and it's negative, so this is negative 10. And we can see that just by looking at it, but how would you calculate it? Well, you're going from here to here. You're starting at 6 and you're going to negative 4. Okay. If I go from milepost 14, okay, or is it 15 or 17? Yeah, it's 15, I think. But it's actually 14 because the milepost is in the middle of the bridge, but a little toward this side. Okay, and the number from down. Anyhow, that's not too relevant. If I go from milepost 14 to milepost 19, how do I calculate the result? And so if I want to calculate this, and it's easy to calculate, I'm going to do -4 minus 6 equals negative 10. Okay, in both of these, you might have trouble reading that, but it's the ending point minus the starting point. Okay. Well then, can you tell me what the slope is between these 2 points without using a formula? M is a slope. Slope is rise over run. And you see what the rise is and what the run is. The rise is negative 10. Which is negative 5/3. And it makes sense. It has a meaning. Now you also have the formula for the slope, and that's what everybody used. And I'm not being critical. That's what OpenMath showed you how to do. Okay. You're doing exactly what OpenMath is set up to do. And I can't find anything in OpenMath and don't have time to write things in OpenMath to emphasize the geometry. And OpenMath is not particularly useful for geometry. Okay. Geometry, I think, requires hand sketches and pictures in a way that's difficult to do through OpenMath. Okay, now one clear disadvantage of looking at a picture is you can do what I just did and not look at it carefully. That's 7, not 6. And of course, you recognize this as the slope that you calculated without using any picture. And probably, depending on what OpenMath did for you, and OpenMath, it did what it did very efficiently because y'all did well with this, okay? But it didn't necessarily give you a picture. It's possible to get the answers in OpenMath without ever picturing anything. And I'm not speaking against OpenMath. It's just every format has its shortcomings, okay? Have things that are more difficult to do with that format. So this is why I'm telling you what it means because the picture is going to stick with you much longer than those formulas. Okay. If you go from the pictures to the formulas, then you're not likely to make mistakes. Okay. So anyhow, there's the slope. All right. Now, don't look at your work or don't remember anything you did if you can keep yourself from doing it. What do you estimate the coordinates at this point are? What do you estimate might be the y-coordinate at that point? Here's 6. What number would go with that? Okay, that's the same number I would have had. Okay, now everybody estimated. We have an estimate of y equals 9 here. So now we have an estimate of what the equation of the line ought to be. You can actually calculate this using similar triangles, but you're not probably going to want to go to that trouble, and we don't have time to talk about that. The y-intercept is estimated to be at the point 0.09. So what's that tell you about the equation? Tells you that b should be pretty close to 9. Now we're sure, if we've counted correctly, that the slope is negative 10/7. And I'm pretty sure that's what I saw in all the papers. And everybody had the same thing. Okay, so this wavy little thing above the equal sign means it's approximately equal to negative 10/7 plus 9. If you use the equations, which you know how to use, the formulas, just pick the numbers out of the air here. Okay. -4 minus 6 over 9 minus 2, which is negative 10 over 7. That's no surprise because the picture told us that. And the formula had darn well better match the picture, but we understand why. It's y2 minus y1. We get this by subtracting 2 from 9. In other words, it's the second coordinate minus the first coordinate. Second x coordinate minus first x coordinate. Sorry, second y, yeah, so second x coordinate minus first x coordinate. That's y2 minus y1. Here's y1, x2 minus x1. Here's y2 minus y1, which is negative 10. Okay, b, well, how do you get b? This takes a little bit more work. I think, and I really should have double checked to make sure this is what they do, but I think they then tell you, you write, okay. So y is negative 10/7 x plus b. Then you plug in the coordinates of one of your points. That is what you did, isn't it? Okay. y equals 6 if x equals 2. So you get the point, you get the equation 6 equals negative 10/7 x, 10/7 times 2 plus b. That makes sense? Is that what you did? Okay. You don't have some big formula for b. You could make a formula for b. You could just solve this for b. You'd get b equals y minus mx, and then plug a values of x and y for one of the points, and you would get it. Well, anyhow, this then works out. You can solve for b, and you get the equation of the line without ever thinking about anything but the formulas. Okay. You understand how this picture is more informative than just the formulas. Now, I don't know to what extent. I'm sure you saw pictures, and I'm sure, as some of you said, there were videos related to the picture that used the pictures. Okay. Now, there's this thing that I'm going to mention this briefly because it's not going to be used in anybody's class but mine, I don't think. I call this the fundamental triangle. And it has the rise here and the run here, and there are directions, okay? So it's useful to focus on this triangle, especially when you get to an applied calculus or full-blown calculus course. Most people in pre-calculus have some sort of a calculus course in their future. And this can be very valuable. I'm not going to explain why at this point, but we probably will talk about that in pre-calculus class, because pre-calculus is pre-calculus, preparing you for calculus. Okay. Okay, so we're going to talk a little bit about proportionality. To say that y is directly proportional to x, we mean that y equals kx some fixed value of k. What would the graph of y equals kx look like? Okay, so let me just comment. I asked a question and I pretty quickly got the answer. Well, yeah, it has to be linear because x isn't squared, it's not cubed, it's not in the exponent like in 2 to the x or something like that, right? It's not a square root, it's not a reciprocal, it's none of those things. It's just plain old kx. So it's a linear function, a linear equation. This is a linear function. The slope is k because the slope is whatever's in front of x. y-intercept 0. Why is the y-intercept 0? Well, the y-intercept occurs when x equals 0. If x equals 0, kx is 0, so that's the y-intercept. It's one way of saying it. The other way, it matches up with y equals mx plus b if k is the same as m and b is 0. So this is y equals mx plus b. M equals k, you replace m by k. And b equals 0. So its graph is just a straight line through the origin. Okay, now, question. Y equals kx and y equals 12 when x equals 4. What's the value of k? Okay, well, formally, we can write this as substitute x and y values into the equation y equals kx. You get 12 equals k times 4. Well, you divide both sides by 4 to get k equals 12 over 4, which is 3. Make sense? Now, that's easy. So that's a step you got to start with. Okay, now, what should y be if x equals 7? So what we can do, okay, now, I've just written it down. The big deal here is that k doesn't change. You found it, so for whatever this situation is, that's what k always is. And why doesn't k change in terms of the definition? We said y equals kx for some fixed value of k. Underline fixed value. So y equals 3x. So if x is 7, y is 3 times 7. Just plug 7 in, right? And if you wanted to find a certain value of y, I say, okay, what would x have to be in order for y to be 47? You plug 47 in for y, you get 47 equals 3x. Divide both sides by 3, you get x equals 47 over 3. Okay. So the process here, we can write down a procedure Spell, but I didn't do a good job of it there. Write the proportionality equation. What's the proportionality equation? Well, for this case, the proportionality equation would be y equals kx. Use the information to find k. Okay. In the current example, it'd be 12 equals k times 4, so k equals 3, 12 and 4 being given values of x and y. Then, important step that people tend to want to skip. Rewrite the proportionality equation. For example, y equals 3x in the example we just did. Use the equation as appropriate. For example, x equals 7, find y. Or if y equals 47, find x. Okay? Okay, now, not surprisingly, you would call y equals kx a linear proportionality. What do you think would be the formula for a cubic proportionality? Okay, we haven't even really talked in my class about linear functions. We've talked about quadratic functions and cubic functions and exponential functions and reciprocal square, okay? And square root recently. Well, okay, it's a proportionality to the square of x. It's a proportionality to the cube of x. Okay. Y equals k times the square root of x. Proportionality to the that's a little hard to read it, right? The square root of x, right? And I should see that. Okay. Now there's another kind of proportionality. Okay. Now you would probably, based on what you've seen in pre-calculus, call that a proportionality to the reciprocal of x. But we're going to say it's an inverse proportionality because you know from graphing the reciprocal function that as x gets bigger, y gets smaller. Here's your curve, right? For positive x, the curve for the reciprocal function looks like this. And y gets smaller as x gets bigger. So we're going to call this moving out letters. That word is inversely proportional. Okay. Now, what about y equals k times 1 over x squared? And let's see the camera. Seems like if I walk too close to it, it panics. Can't blame it. I don't think I'm that scary, but apparently the camera does. Okay, there it is. Okay, y equals k times 1 over x squared. Now let me pause a second. Okay, we say this is with the inversely proportional to the square of x. I'm not going to, yeah, maybe I should. Okay, y is inversely proportional to the square of x. Okay, so these are the main ones you're likely to see. Also, see if you can give me a phrase for this one. Can you put words on it? Okay, y'all are on a roll. Keep it up. It's hard to write down here at the bottom of the board. There's no excuse for how badly I wrote the word square, but that's a word square. Okay. Make sense? So you've got 3 proportions here, 4 proportions here. Okay. And you got 3 down here. And these 4 are proportional to or directly proportional to. Okay. You don't necessarily need the word directly, but you're going to see it. You'll understand it if you understand the scheme. And the procedure is exactly the same for any of these. It's just you start with the correct proportionality. If y is proportional to the square of x, then you plug the y and x values you know in here, and x is going to end up being squared. I'm sure that doesn't come as a shock. Okay, I'm sure you understand that. Okay, let's see. I'm having all kinds of problems with these boards. I just want to draw a slide picture down that over. Okay, so in the camera you can't see all the stuff I wrote over here. Okay, so I have to find something before I give you the information. Okay, y is proportional to the cube of x, and y is 54 when x is 3. Find y when x equals 2. Now, if I didn't have this written up here, since you've only done one of these and you haven't really done it, but you haven't figured it out yourself. Here's the procedure. So what's the first step of the procedure? No, people are hesitant to write down the equation. Some people have written down a wrong equation. Some people have written down y equals kx. This is an example that goes back to the first example we did. It doesn't apply to this, okay? So if you wrote y equals kx, well, you wrote a proportionality equation, that's good, okay? But it's not proportion, it's not a linear proportionality. This is only for linear proportionality. That was the example that we started with. This time, we have a proportionality to the cube of x. How do you write a proportionality to the cube of x? Well, right here I've listed them, but you were able to interpret these. You've got a pretty good idea. You just have to solidify it a little bit, okay? So you write, in this case, and I'm going to preface it with use of the word. Now y equals kx cubed. This is step one. We identify the type of proportionality and we write it out. Step two. Use this information to find k. Now we're short on time, so I'm going to work through this, but I think you're going to understand. Okay. Okay, you put the 54 in for y and the 3 for x. 4 goes here, 3 goes here. And then you just do the arithmetic. Now, sometimes you're going to have to use fractions. Okay, but I've decided to make it easy on you. And I don't recommend using your calculator to get decimal equivalencies, although sometimes it's okay. You have to know how far you should have to round it depending on the situation, and that's a little bit complicated. And I prefer you work with the fractions anyhow, because that's always a weakness that's going to bite in about 3 or 4 weeks, okay? So we want to be able to work with fractions. Third step, rewrite the equation. Well, on the example we started with, we found that k was 3, and now y equals 3x. This is an example. E.g. means like for example. It doesn't mean you always write y equals 3x. Okay? So down here we write k equals 2, so y equals 2x cubed. The arithmetic and the algebra here are extremely simple. You just have to know the 4-step procedure. Or if you look at alternative procedure, I think OpenMath does a pretty good job with this, especially with showing you why this is important. They have some great examples, and it'll be illuminating for you. Okay? I think the OpenMath assignment on this is really one of the better ones. One of the best. They're all pretty good. Then use the equation as appropriate. What's this mean? Well, we've got a question to answer. It'd be appropriate to answer that question, wouldn't it? Okay. And there it is. Okay, you just plug x equals 2 into this. You don't try to plug it into here because you're done with k. You found it. It's always the same. It never changes. There's your proportionality equation. Okay. I think you're going to do very well with the assignment. Try to focus on understanding the language of proportionality and inverse proportionality, and then just do the algebra. I think you're going to be very successful in that assignment. Now, there was an assignment on slope and interpretation of slope, but I've moved that till after the Tuesday class because you're going to be much better with interpretation after you do the proportionality stuff. That doesn't mean I'm giving you a free pass over the weekend, because the proportionality assignment is, if you understand it, you can really work through it pretty quickly. Okay. And I think you're going to understand it. I do want you to do the thing on adding and subtracting fractions. Okay. We just want to reinforce fractions at this point. It's a good place to put that in. Okay. Because I don't want to talk about the interpretation of slope until you've done the proportionality.